This washer residue does not show that routine eco use causes early repairs. Eco labels describe resource settings, not a guarantee against every maintenance issue. Standing water near a filter signals drainage trouble, not its original cause. Cloudy glasses and grease show poor results, not proven cycle damage. A long timer can reflect slower soaking rather than greater energy use. Visible washer residue calls for diagnosis, not an automatic eco repair story. Compare racks, spray arms, filters, and clean results before choosing a machine. A technician checks standing water methodically because several faults can look alike. Greasy residue may reflect loading, detergent, water conditions, or block spray. Elapsed time reveals duration, but not heater demand or pump duty. Washer film can involve excess detergent, retained moisture, and miscare. Accessible seals and filters matter, yet every model requires its own instructions. A green setting beside murky water is correlation in one frame, not causation. Clouded glassware deserves troubleshooting before anyone blames the selected program. Longer programs can exchange heating intensity and water for added soaking time. Dark seal deposits can indicate buildup, though they do not diagnose failure. Filter access and spray paths differ, so maintenance cannot follow one template. Investigate drainage symptoms through the manual, then seek service if they persist. Residue beside an eco control illustrate a question, not a demonstrated mechanism. The clock shows elapsed time only. It cannot forecast bearing wear. Biofilm and malodor can develop on washer surfaces under some conditions. European Union rules define and test covered eco programs under specified conditions. Those performance requirements do not establish durability or explain this drainage symptom, nor do they guarantee perfect cleaning for every soil level or load. Published cycle duration belongs beside measured energy and water figures, never alone. Seal film calls for approved cleaning checks, correct dosing, and moisture control. Use eco only when your manual assigns it to that specific load. If water remains, inspect only owner-serviceable filters and approved drainage checks. Poor results may justify changing setup or program, not inventing damage. The technician's best tool here is the exact model's program guide. A workbench compares residue, filters, pumps, hoses, and detergent variables side by side. Calibrated meters separate inlet heat, power draw, water use, and cycle duration. Bench comparisons can explore cleaning trade-offs without claiming universal appliance behavior. This filter catches softened food before particles reach the drainage hardware. Manufacturer instructions define approved eco use and each model's specific maintenance boundaries. Bills and repair invoices become meaningful only after diagnosis and context. Repeated measurements show why elapsed minutes cannot substitute for actual consumption data. Lower heat may pair with longer soaking, depending entirely on program design. Food trapped here shows filtration working, until neglected buildup restricts flow. Only the manual can identify whether this filter is owner removable. Household costs vary with fault, age, labor, warranty, parts, and location. Handheld meters capture current readings, not future pump, sensor, or bearing failure. A controlled bench can compare cleaning outcomes, but durability needs different evidence. Softened particles in a filter do not prove eco created the debris. Program charts vary across brands, markets, options, and even related models. A saucepan on an electric cooktop illustrates that efficient settings vary by appliance. Researchers must record component duty, load, pauses, speed, and heater demand. Without those variables, a longer timer remains a weak reliability theory. A filter protects drainage parts only when its design and condition allow. Approved inspection steps prevent damage from forcing unfamiliar clips or covers. Vacuuming an accessible appliance grill shows maintenance, not proof of eco damage. Measurements can reveal consumption today, while repair risk requires reliability evidence. Grease removal changes with soil, chemistry, water, loading, temperature, and time. Trap food points toward filter care, never automatically towards cycle damage. Specific manufacturer instructions outweigh any universal schedule copied from another appliance. Correctly positioning a window air conditioner still depends on model-specific installation guidance. Inlet temperature and power readings describe one particular test, not every household. Side-by-side grease tests need comparable loads, detergent, water, and program conditions. The filter's contents suggest what reached it, not why machinery failed. Transparent flow shows how lower heat can pair with longer washing. Soap, Minerals, fat, and food can accumulate when conditions mismatch the load. A sensor extending time reflects program adjustment, not evidence of impending failure. Crowded baked-on pans visibly combine heavy soil and impractical loading choices. The cutaway traces spray, filtration, pumping, and drainage as separate functions. Warm moving water illustrates one possible trade-off between temperature and soaking time. Visible buildup supports checking setup and care, not blaming one mode. An empty washer drum reveals no cloudy water, sensor response, or damage. This overloaded rack is unsuitable evidence for judging a normal eco load. Water passes through spray arms, filter, sump, pumps, hose, then drain. Slower washing can reduce heating demand, although exact strategies remain model-specific. Deposits here could reflect poor spray, excess detergent, minerals, or heavy soil. Extended duration alone cannot reveal motor load, pauses, or component stress. Baked cookware needs the program assigned by the manual, not wishful loading. Mechanical pathways help localize symptoms without turning correlation into an eco-accusation. Long soaking may compensate for gentler heating during suitable dishwasher programs. If residue persists, compare loading, dose, hardness settings, spray access, and filters. A handheld gauge offers one reading, while the manual defines normal operation. Dirty results from this crowding cannot isolate the selected cycle as cause. Each connected component has a function, yet images cannot measure wear rates. Warm water around grease demonstrates cleaning conditions, not guaranteed performance everywhere. Film accumulation remains a symptom whose source may involve several variables. Visible droplets and a sensor fitting still cannot establish future component damage. Heavy pans packed tightly can obstruct jets and prevent detergent reaching surfaces. Troubleshooting should follow flow from spray through filtration and drainage. Lower heating with more time can save energy in some dishwasher designs. That trade-off may leave visible residue when the chosen load is unsuitable. Eco controls and an analog timer show settings, not mechanical condition. Overloading supplies an obvious competing explanation for unfinished baked-on cookware. This working rig shows normal flow and particles contained by filtration. Warm parts prove appliances fail, but not that eco caused those failures. Installing a refrigerator shelf illustrates setup, not evidence about eco-cycle maintenance. Identical machines can differ because loads, dosing, hardness, and care differ. A clogged filter can restrict drainage, while connected parts require separate inspection. Mineral deposits and greasy sensor film suggest water and maintenance questions. A worn pump beside stained seals still cannot reveal its failure history. Utility savings and repair costs require probabilities that these papers cannot supply. Fair comparison controls soil, loading, detergent, hardness, maintenance, options, and age. The illuminated blockage is diagnosable evidence, unlike assumptions based on elapsed time. Clogged fittings inside clear tubing support inspection before blaming any program. Service records may explain heavy use, but cycle attribution needs direct data. Opening an oven invites appliance-specific checks before attempting any owner maintenance. The crowded, foamy machine demonstrates confounders rather than a universal eco outcome. When a filter clogs, follow approved removal steps before considering deeper service. Scale-restricted jets and coded sensors can warrant model-specific inspection or service. These damaged components are diagnostic examples, not evidence against every eco program. A household calculation must keep uncertain failure probability separate from measured savings. Different water and maintenance histories can produce different outcomes from matching appliances. Filter restriction is one plausible drainage mechanism, but its origin still matters. Wet debris around a small tube supports inspection, not automatic diagnosis. A repair bench cannot reveal whether age, misuse, defect, or chance dominated. Invoices describe one repair after it happened, not general future risk. Side-by-side appliances expose why universal claims collapse when operating conditions differ. A technician's lamp can locate obstruction, while the manual defines safe access. Mineral and grease deposits call for diagnosis, not an automatic repair forecast. Pumps, sensors, and seals genuinely fail through many possible mechanisms. No fixed repair price works across countries, brands, access, parts, or warranties. Matching machines still need matching loads and histories before results are comparable. This blockage may burden drainage, but routine eco use remains in proven upstream. Coded openings and sensors point toward water conditions and neglected maintenance. A pulled appliance shows repair disruption without revealing what caused the fault. Murky water and an estimate show consequences after failure, not eco-causation. Damp laundry and seal buildup justify checking drainage, dosing, moisture, and care. Removed parts can confirm a blockage once a technician completes proper diagnosis. Modest water differences beside a failed pump do not establish a causal trade-off. Kitchen disruption is real, though the pictured repair reveals no cycle history. Standing water warrants approved checks, then qualified service when symptoms persist. A service code needs the model guide. Residue nearby may be unrelated. A technician can explain confirmed obstruction without generalizing its cause to eco. Small owner maintenance and major repair differ sharply, but prevention is conditional. Once cabinetry is opened, leave sealed components and safety systems to professionals. An estimate should name the diagnosed fault, parts, labor, and warranty status. Months of skipped care may contribute buildup without proving mechanical damage. Actual debris can support a blockage finding better than speculation about settings. This ledger is one household example, not a universal cost equation. Repair access can inconvenience a family regardless of which program preceded failure. Murky drainage and paperwork show why diagnosis should come before price comparison. Persistent faults after manual approved checks belong with qualified appliance service. The removed filter demonstrates maintenance evidence, while deeper failure needs professional confirmation. A clogged filter and damaged pump illustrate hypothesis, not proof of origin. Disassembly and replacement show repair scale, while causation remains outside the frame. Water left beneath racks confirms drainage failure, not which choice produced it. Seal residue beside stalled laundry supports cleaning and drainage investigation first. Explaining a confirmed blockage should include design, maintenance, loading, and water conditions. Even pictured cleaner is appropriate only when exact appliance instructions approve it. A microwave control and small label point back to manufacturer instructions. The repair estimate becomes useful only after the fault is clearly identified. Removing a range hood grease filter demonstrates accessible maintenance beyond washers and dishwashers. Owner visible evidence may guide questions, but a technician should verify deeper damage. Simple care beside replacement hardware shows stakes without promising every repair is preventable. Disconnect is instructed before approved filter, spray arm, seal, or drain checks. Run a maintenance cycle only when your manufacturer specifies the program and product. Two open ovens reinforce why maintenance routines differ across appliances and loads. Clear glassware can reflect good loading, suitable detergent, filtration, and program choice. A handheld meter supports measurement, while exact manuals define appropriate program use. Remove and rinse only filters designed for owner access, following refitting steps. A dryer duct connection requires model-specific inspection rather than generic cleaning advice. Alternate programs by load and instructions, not by a borrowed weekly formula. A cycle log can track outcomes without pretending to prove future reliability. Use program definitions for normal soil, heavy soil, delicates, and hygiene needs. With power isolated as directed, inspect accessible spray paths and drainage parts. Never substitute homemade acids, bleach, vinegar, or unapproved cleaners for instructions. Greasy loads may need another listed program, while ordinary loads may suit eco. Clean dishes avoid a rewash, but comparisons still require published consumption figures. If eco repeatedly disappoints, check setup, detergent, filters, and program assignment. Wipe seals and clear spray openings only by the approved owner procedure. Use only the cleaner, concentration, location, and method your instructions approve. Schedule care from the manual or machine reminder, never a universal calendar. Bright glasses suggest success today, not immunity from every future fault. Before each unusual load, consult care labels and the relevant program guide. Filters, arms, seals, and drains differ in accessibility across appliance designs. Manufacturer-approved care may address buildup, but cannot retroactively explain every breakdown. Eco may fit normal loads. Stronger or validated cycles may fit others. Success means appropriate cleaning with measured resources, not simply the shortest timer. Let model instructions decide when eco fits and when another program belongs. Approved filter and spray checks can support performance without entering sealed machinery. Washer filters and maintenance washes likewise require exact model instructions. The evidence supports suitable eco use, correct dosing, moisture control, and approved care. Clean glasses close this case because eco is not an established repair cause. Wiping an open microwave shows simple care must still follow instructions. Rinse filters. Watch the false promise of flushable wipes. the real plumbing bill.